Well, hello everyone. Welcome to another NSF live stream, but this is a special one. This is the first episode of a new edition of NSF Live, which we've called Europe's Future in Space. And this is going to be a months-long series of live streams where we're going to talk with European industry officials live here on NSF. And we're going to, so that you, the audience, can get to know them better and also get them to have a space to talk about all the cool things that they're planning for the future. Roll the intro.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Following up. Roger, planet.
Water towers fly!
Tango down to nominal.
Fighting downside SPD off. Bring in SPD off. It's orange!
Orange 25. Oh my god! Oh my god!
Decollage. What is it? Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? We don't need any more of these.
Well, I saw already all of those 555s in chat, and well, you know me already. I'm Alejandro Alcantarilla, the guy with the long name here at NSF. I'm a writer and host here on this live stream. But it's not going to be me, of course. It's going to be our guest today will be the first of this series, which will be Raúl Torres. He's the CEO and co-founder of PLD Space. How are you, Raúl?
Hey, what's up? Good. Everything okay?
Fantastic. And so, alongside, we're also going to have Dee in the background, picking up some questions from you in the chat and, helping me a little bit here on my first, time hosting a live stream. Thank you, Dee.
Of course, anytime.
And also thanks to Jay as well. He's operating in the background as well, doing all of the producer stuff. But, let's get down to business. Let's get down to, this big live stream that we have ahead for us. And, Raul, one of the things that comes to mind as a Spaniard is like what is it for people that are outside that don't know what PLD Space is doing? Like, what would be your elevator pitch of what you guys do?
Well, quite easy. We are a space transportation company. So our work is basically developing from the ground up a launch vehicle and put satellites and other cargo into orbit.
Yeah, so essentially just like, bunch of other companies as well, right?
Yeah,
But
exactly.
how is it that, as a Spaniard myself, it's like, wow, a launch company from here. It's here in Europe. It's always been the French, the Germans, a little bit also from Italy, but from Spain, it's been very rare, right? How come that, suddenly we have this company? Can you tell us a little bit about the origins of this PLD Space company?
Yeah, so we founded the company back in 2011, so a long time ago, when there was a moment where no German companies existed. Only France was launching Ariane 5 and first launch of bigger vehicles. So it was like early days on the, let's say, new space, or a new space also in the US, but like the very, very early days in the new space of Europe. So actually, when we founded the company, the small satellite market for business was so tiny, and not so many people was doing small sats. We started calling those small sats CubeSats, and today CubeSats is just one of the small part of the market of those, let's say, called small sats. So we were doing our business plans, checking the evolution of the market, and seeing that every single time we were like having data from prospecting market. Every single time, the market was larger and larger. And vehicles were so big and thinking their use into in other type of missions. So that was the very early day moments for funding PLD Space, and we funded the company without money. Yeah, 13 years ago, years later, we are like close to 300 employees. We launched Miura 1 last year, and we are like 1 year away of having Miura 5 ready for launch.
I cannot wait until we see that. Of course, we're going to be talking about that as well today. But you know, just about those rockets, you called them Miura. Can you explain a little bit what's the origin of that? Because it's always been puzzling for me.
Well, actually, before calling Miura, we had another name what was called Arion, which is like in the Iberian mythology was like a horse, a powerful horse, but was very similar to Ariane vehicle, which is quite common name in Europe for European launch vehicles in the institutional market. So there was one time we, let's say, were like suggested to change the name, and we changed it into something more powerful even than a horse, which is a bull, Spanish bull, which is a very common name in Spain for certain type of bulls. And we decided to keep this name, which is bringing into the team and into the company like powerful, like something like pure to as a name, and that was the name. And actually, years later, we saw that this name is extremely popular in Japan, so makes us also happy because the name Miura seems like a surname, quite common surname in Japan, which is I didn't know that, and now it's quite funny, yeah.
Yeah, that's really interesting. I completely I didn't know about that, but I guess, you know, all of these traditions carry over there. And so you guys started with like, you know, just doing small scale stuff, right? Like I remember for a long time we were sort of waiting for Miura 1 to become a thing. Then it became a thing. Then it launched. We can see here a little bit of that launch here. Like how did you even get to that point? Like, it seems crazy to me. We're actually talking before the show about how we saw from here, from my country, a launch into space. It was like this sort of phenomenon, you know, in the news and everywhere. Like, how did you decide to come to Miura 1 and not go perhaps to an orbital rocket? Let's put it that way.
Yeah. Well, actually, is the in some cases is the classical way. So doing from zero to orbit, to orbital class launch vehicle like other PLD competitors. But at that time, when we founded the company, like 13 years ago, was complex to, let's say, to defend that without no experience, without not so much amount of money, and no infrastructure and previous country experience, let's say. Doing an orbital class launch vehicle was extremely hard to defend. So we define a first type of vehicle called Miura 1, which was not the final one that was launched. So the first versions of Miura 1 has 2 stages. The turbo pump of the first stage was a more complex vehicle with the goal of even being very close to inject some small payload amount into orbit. So that was the very early days Miura 1 designs. The problem was funding that, where we had to find the economical resources to fund the program and to finalize it. So was hard to do. And then we redesign again the vehicle with a single stage, pressure fed, and much smaller compared with the other one. But at the end was a 3.5-story building, tall, which is not small, close to 3 tons at liftoff, so was large. And that was actually the Miura 1 that we launched last year. Until reaching the point of the launch, the company invested specifically in Miura 1 development, close to 50 million. And we are now, let's say, totally focused on Miura 5 with that success of Miura 1.
Yeah, I remember when I went out to see the Miura 1 out there at the pad, you know, I was thinking it was going to be this sort of small, like, it was obviously built as a small rocket, right? That's some of the stuff that I recorded that day. And the thing is, when I saw it, it was being, in this sort of environmental thing. They showed it to us, and we were like, "What?" It's actually a lot larger, and now
Yeah.
that thing went up in space. Like it just felt different, right? Seeing it in person and
Yeah.
being able to actually be there.
Yeah, it's actually quite common. People, when they say, no, it's a suborbital rocket, well, it's one of the largest suborbital rocket ever launched. So it's a big suborbital rocket. And even when we were doing the studies for safety and operations, the vehicle was more even larger than the way we can feel comfortable for launching in the launch base we were using, which is a military base in the southwest of coast of Spain. So Miura 1 is larger than a lot of people is thinking. It's using a pressure fed engine, so it's not turbo pump fed, which is something we will talk later in the interview with. It's one of the largest suborbital vehicles launched. And we didn't reach space, so we didn't pass the Kármán line, let's say, because it was not planned to do that based on, as I mentioned, based on safety conditions for ensuring that the launch range was secure enough. But the vehicle, as you can imagine, or you actually saw in the pad, is larger than you expect. Yeah.
Yeah, I was quite impressed, and it was a real pleasure being able to be there. And I'm being cute that we also have, there you go, my signature flew on that rocket as well with the NSF logo. That was really brilliant and very precious, to be able to be on that rocket. So
you have to do the same for Miura 5.
I'll I'm gonna have your word for it.
No. Yeah, just talk with our communication team and you will do it. Yeah, Maria said it.
Yeah, I remember when I went there to the Beyond event, you sort of talked about, how you want to put together a Miura 5 in a year or so. And so I'm gonna take your word for it, and we'll definitely try to be there again for that. And so how do you take that step from like Miura 1 to Miura 5? Because if I remember correctly, Miura 5 is like, now it's not pressure fed anymore. It's a turbo pump engine. You need to develop all of these new technology. How do you get to that decision on the design?
Yeah, well, in some cases, there are some technologies we are trespassing from Miura 1 to Miura 5. For example, structures, design, analysis, or manufacturing. We are using SIM aluminum, for example, on structures. We are using improved techniques for production, but in let's say as a production process is the same production process. So like barrel curving, machining, welding, so it's the same manufacturing techniques, let's say. So what people used to think is that when you are passing from one type of vehicle to another, you are starting up from the ground. Let's say everything is made from the ground up, and it's not true, because you are passing lots of technology, direct transfer of technology, in some cases even transpassing hardware from one type of vehicle to the other, which is already generally components that has been qualified for special ambience, or even COTS components that are even overqualified for Miura 1 and now are fitting perfect for Miura 5 flight loads, for example. In some other cases, we are, let's say, improving manufacturing techniques. For example, combustion chambers in Miura 1 was one type of process. Now we're using a different process, which is, let's say, an improvement. And in other parts is brand new design and brand new development, like turbo pumps, for example. So basically, we analyze more in deep which of those things can have direct transfer to a new vehicle, which things can be improved from one vehicle to the other, and which thing has to be designed from the ground up, which are not so many. We are like pushing the effort on turbo pumps, staging mechanisms, fairing separation mechanisms, and some evolutions on the GNC design. Mm-hmm. We're putting more carbon composites on the vehicle. With Miura 1 had lots of carbon composite, but in general, one vehicle and the other are not so different.
Yeah, and pretty much, I wanted to talk to ask you about another thing as well in that sense, because I've heard you talk about how with Miura 1, so that flight, it was supposed to sort of arch, right? It's suborbital,
Yeah.
and so it doesn't go into orbit. And
Yeah.
then you guys had this demonstration on the reentry of trying to recover that Miura 1. How did that go? Like, what was sort of the goals that you were looking for with that?
Yeah.
Or for Miura 1, yeah.
Yeah, actually, as people can imagine, suborbital flight means that you are going up and going down with a certain height and length, let's say, and downrange. So Miura 1 re-entry was focused on testing one technology called aerobraking, which is basically using the vehicle skin or additional flaps we were using during re-entry process called aerobrakes to basically brake using the friction with the air. The important part of that flight phase is to collect data and gather those data with respect to the pressure distribution along the vehicle and temperature distribution along the vehicle, which is very important to correlate re-entry models. So there is no one easy way to correlate certain type of models, and aerothermal models are extremely hard to correlate because you can't simulate easily in real conditions, except flying, that aerothermal environment. So collecting data in flight was very important. We collected lots of huge quantity amount of sensors in flight, and that has been now used to basically improve the models for Miura 5 ascent and reentry. Reentry in Miura 5 is a bit different because it's a higher Mach number, so not all the data of Miura 1 can be used directly in Miura 5, but there is some parts that we can correlate. And the good thing is that the ascent phase until a certain point can be directly correlated because the flight phase is quite similar. More of that, another important part was the use of the triggering of the parachutes for the deployment. Miura 1 had parachutes for recovering, so final braking and in a transonic regime and subsonic regime. And we were deploying that parachute that actually worked perfectly to brake the vehicle during the descent phase. And in the final phase, the water impact. So this is something that you can see in other space launch vehicles, for example, on the Starship now, for example, when SpaceX is launching Starship and they do the final water impact with the Starship in the ocean. And you collect the data from the loads when you are splashing down, which is something you can think that is negligible, and it's not negligible anymore. It's quite stressful for structure. So that data was also collected, but unfortunately we were not able of recovering the vehicle because seems now, after processing the information, seems that the vehicle was broke by the LOX tank and sink.
Yeah, I remember you guys talking about that. It was also in the middle of the night, if I remember. So
yeah,
it was probably not a good time to.
Yeah, there was two boats. There was two boats at that time, like searching in the middle of the Atlantic Ocean. Not in the middle, but in the Cardiff Bay, searching for the vehicle. To more than 8 hours around and with drones flying, searching the vehicle. But no. And at the point that was, we know perfectly the point where the vehicle was, and was synced.
Yeah,
at least like Starship, like the same.
Yeah, and I guess that's a great comparison, right? We saw that booster and ship, they did not survive the splashdown because of course those are not built for that. So it's always good to have
not,
a model.
Exactly, big vehicle is not always prepared for all the ambience. You can design a vehicle which is very good ascending, like not flying but ascending, but it's not so good being a boat. So.
Exactly. Yeah. And so that'll help you with Miura 5. And if I remember correctly, at one point you talked about having splashdown landings for Miura 5, but then also you guys have talked about propulsive landing. How does that evolution go? Maybe going a little bit now into Miura 5 deeper here now.
Okay. Well, so the first Miura 5 launches will be, we will attempt recovering the vehicle in the ocean. So same, let's say, very similar in the way we did it for Miura 1, using parachutes. So it's a bit different on the reentry phase because we are not going to use aero brakes. We're going to use just the vehicle skin, let's say, for braking and probably additional technologies like a balloon for that reentry. But at the end, the vehicle will splash in the Atlantic Ocean, and we will try to search it. So in the same fashion, we were applying for Miura 1. The problem with Miura 5 is that the vehicle is so large compared with Miura 5, and obviously, since it's an orbital launch vehicle, it's more optimized in weight than Miura 1, which was pressure fed, so structures were heavy compared with Miura 5, let's say, and that reduces substantially the probability of success of recovering the stage with an aggressive splashdown. So it's something we need to test. It's something we need to collect that data, to gather that data, and evaluate how hard is this splashdown process and how we're going to tumble the vehicle into the water. But there is no plan on that vehicle version to reduce it. So we want to just collect the vehicle, analyze more in depth the technologies, both the engines, turbopumps, and the structures, and also the avionics, and see how the re-entry environment is affecting to those technologies and how we can improve from the aerothermal point of view, especially aerothermal point of view, to protect more certain parts and correlate the new models, the new aerothermal models for doing version 1.1, which is the vehicle recoverable and reusable. I'm not 100% sure that that vehicle will be using propulsive landing. We are probably mix what we call 1.1 and 1.2 into a single vehicle, which is an improved version of Miura 5 that can eventually reignite the engines and go back to the path.
Yeah, and that is, you know, now that you talked about the Miura 5 splashdown and everything, I just remembered that you guys actually did a test of sort of like trying to simulate how it splashes down and then recovering it and everything. How did that go? Did you what did you learn?
The test we did was made in 2019, was called LPSR, Liquid Propulsion Stage Recovery, and the goal of that project with ESA, with the support of ESA, the European Space Agency, was to basically simulate. It was a subscale version of Miura 5, was 1.5 meter diameter instead of the 2, and was like 15 meter length instead of the 24 now for the current stage design. But the goal of that project was using a Chinook helicopter, like going 5 kilometers up, drop the stage, execute the parachute recovery process, braking with those parachutes, and finally splashing down in the Gulf of Cadiz and making that splashdown process, turning the vehicle into the water. What we saw was basically that the splashdown was a hard maneuver because basically structures can collapse, which is what happened in Miura 1. But in the other way, we saw more than expected corrosion effects on both aluminum and copper, on the combustion chamber copper materials. So with that, we were iterating and analyzing more in depth how to protect certain parts on the vehicle that can be subject to special corrosion effects and that obviously are not desirable in a reflight. And
you know, that's a great cue right now to the next thing that I wanted to talk about, which is, you know, now you're developing Miura 5. It's still not complete, right? You guys are still doing component testing. And so how are you guys doing all of that right now? Like, what step are you on that process of development?
So now we're in the process. Actually, you see that in back of me, it's a stage 2 LOX tank for it's going to be tested. So basically, we're like deploying all the engineering capabilities. So engineering has been finished. So the vehicle is fully 95% designed. There is always margin for improvement or margin for changes, for needed changes. But the vehicle in general terms is fully designed. Now we're in the phase of deploying manufacturing capabilities and deploying testing. So testing turbopumps, we're already testing turbopumps. We're already testing structures, both pressurized structures, not pressurized structures. We did fairing separation testing. We are qualifying mechanisms. GG gas generator testing. So we're doing everything by now, and that is going to take us next year, the full next year for testing, and starting the vehicle integration by the end of the year, probably. Yeah.
Yeah, I've been told.
Well, not the end of the
maybe...
year. I think October is going to be like next beyond event will be the vehicle. But this is our
Okay.
yeah. The moment the moment where you will see it, that will be October 7th.
Okay, I'll take your word. I told you this last month. I'll definitely take your word. I believe we probably have a lot of questions about what else is in the background behind Raúl, right?
Yeah, we have one question just asking what's going on in the screens in the background. So you already mentioned the stage 2 testing. So what sort of tests are...
Yeah. So what you see my background is there's two things. One, this part is liquid oxygen, stage 2 liquid oxygen tank. We're going to test it in a buckling test. Obviously, loading propeller loading and buckling testing using hydraulic mechanisms for, let's say, for compression testing and buckling. And in the other part, this is it's actually the Miura 1 test bench for engine testing, but now has been redesigned and converted into Miura 5 turbo pump testing bench, where we do the cold testing and the hot testing of the turbo pumps, both running propellants through the pumps, kerosene and liquid oxygen, and adding into the turbine spin starter, running the turbine with nitrogen or with helium and the GG and the gas generator.
Awesome.
That's really cool. Do we have any more questions from chat?
Yeah, we have a couple more questions. So back at the beginning of the stream, Ross was asking what you see as the greatest technical challenges in getting to orbit.
Yeah, I think engine qualification would be, because I'm not afraid on structure, both testing and qualification, my team will be, but not me. I think that it's like more challenging than Miura 5 because of the size, but definitely my team can do that. But engines are quite different. As we were testing before, Miura 1 used pressure-fed engines. Was a large pressure-fed engine, but was a pressure-fed engine with no rotating parts, like a turbo pump. Now we're in the phase of testing the turbo pump, testing combustion chambers, quite large compared with Miura 1 ones. So I would say from now to orbit, hardest, I will add one, but hardest part would be engine qualification, and second part, I would add staging. So staging is something we're going to test before flight in a specific bench called T9 is the name of the bench. So that bench is going to be used for stage separation studies of the dynamic part and the mechanisms part, both the pushers and retainers for staging. But obviously, separating in flight something is hard. It's something naturally Miura 1 didn't have, but I would say that both engine qualification and staging are going to be the trickiest paths to orbit.
All right, and I'll do one more. We had questions on if rideshare will be a part of your big business plan moving forward, if that's something you've explored.
Yeah, actually, when my team is talking with customers, they ask for dedicated services for certain missions where they can't combine their satellites with other customers because orbits are quite specific. But definitely for small sats, rideshare is the, let's say, pricing point of view is the most optimal solution. So obviously, there's a lot of people asking, hey, how you are going to compete in the rideshare missions with SpaceX and transporters missions, so on. But it's not the same at the end. It's not the same going into a certain type of orbit that going in a more dedicated or premium flight. But at the end, yeah, rideshare mission is going to be quite demanding for flights.
Awesome.
Yeah, and I also saw, like, right off the side of my eye, and I have it also queued here as well. Sort of all of the things that I would like to ask you, which is, you have this no earlier date of potentially end of next year for the debut of Miura 5. But for everybody that may not know where Miura 5 is going to be launching, like, can you tell us where it's going to be launching from? Maybe a little bit of details about what's the design of Miura 5, just so people can get to know the rocket as well.
Yeah, for sure. So Miura 5 launch vehicle is a 2 stages launch vehicle. So using liquid oxygen, kerosene on both stages. Stage 1 has 5 engines at the name also of the name for 5, Miura 5, but has 5 engines on the first stage, 190 kilonewton each engine. So like giving like close to 1 meganewton at sea level. The stage 1 uses, as I said, 5 turbo pumps on the first stage, and the arrangement of the engines is like is the same of Saturn V, like a cross with a central engine and 4 engines on each square. We are using like close to 23 tons of kerosene and 32 tons of liquid oxygen on board, and then the helium and nitrogen for RCS and stage pressurization. We are using helium passing through the turbo pumps in a heat exchanger for warming the helium and increasing the pressurization capability of the helium. Later, we have stage separation mechanisms using nitrogen with basically a pusher and retainer that or retains or push staging during the second stage during the process of staging and separate second stage. So second stage has close to 11 tons of propellant, both using a single engine, separate CPAC, 75 kilonewton, and later we have a fairing close to 6 meter length fairing, which is the one, let's say, protecting the satellites during ascent. So the flight is expected to be from French Guiana, so the European spaceport in French Guiana, in a dedicated space pad we're going to build. Actually, the civil construction is going to start before June this next year. So basically, the pad will be ready by the end of the year for transporting stage to French Guiana and try to make the first launch attempt. But the pad is going to be start building by June, around June probably, not more than June, because we will start the rainy season and will probably affect. So basically, we're going to do that, and that's our effort for that, which is basically the largest limitation for the first flight. The vehicle will be ready, as I said, in October, and as soon as we have the pad ready, we will transport the stage to French Guiana and to do the first mission. First mission is expected to be, which is what we call inside the reference mission. So reference mission is a 500 kilometers synchronous orbit, circular orbit, as a reference, and that's the mission we're going to launch in the first launch attempt. We're now discussing with potential payloads for the first flight inside of the framework of the Spark initiative. We launched it early this year, and probably we will put some extra payload for that first launch attempt.
Yeah, I find that program very exciting because you guys are essentially given the chance of multiple different either agencies or businesses to be able to take a little bit of risk, but they are able to ride on that.
We receive more than 100 applications for the Spark program, and we're still receiving actually from different countries, and it's quite interesting because we're receiving from Europe, from the US, even from Africa, Oceania, so all the places around the world, people coming from schools, high schools, private companies. So everyone wants to launch something like small CubeSat, from 1U CubeSat until 16U, even more U CubeSats, and some of satellites that are not following the CubeSat standard, let's say, so are more, let's say, that can bring operational capabilities, let's say, instead of being like more academic or test articles, like, let's say. So it's quite interesting. Obviously, it's a first test launch. We're going to try to reach orbit at the first, and we know that this is something very hard to do. Not so many companies has been succeeding at the first, reaching orbit. We can see the story of the past 5-10 years. And I think there is probably one reaching orbit at the first. And that obviously is because of the challenge is much harder than launching Miura 1. But I would say that having Miura 1 experience from the operational point of view, we feel that we are going to be prepared for attempting a real orbital launch attempt. Because we launched Miura 1, we learn a lot, we deploy the operational capability. My team has that experience. We tested 2 stages. We tested Miura 1 from the qualification, running static testing on the stage. We have any fire on the stage. Then we had three launch attempts, 2 aborts, and this launch that actually was a 100% success. So I think my team will be prepared, but obviously launching to orbit in terms of complexity, energy that you bring to the mission is much harder than doing that. I think the last company that launches a brand new vehicle and reached orbit was SpaceX with the Falcon 9 version 1, so the first version. I don't remember that any other company has had success at the first launching into orbit. So it's going to be tricky, but we will be prepared for that.
Yeah, and I wanted to ask you about, because people might not understand, maybe perhaps, because we've talked about the size of Miura 1, you've talked about the design of Miura 5, but we haven't got into the part of what's the size and what kind of payloads you will be launching, right? And from what kind of orbit and things like that. So can you tell us a little bit about that?
Yeah, sure. So Miura 5 is 11-story building tall. It's about 34 meters length, and can bring from 1 kilogram to orbit to 1 ton. So depending on the orbit you are achieving, depending on the type of orbit you are reaching, it's not the same equatorial orbits than sun-synchronous orbit. So depending also on the azimuth you are launching, the performance is going to be variable, let's say. But in general terms, you can launch from a mill brick, as we can imagine. It's like tiny satellite, 1U CubeSat, 3U CubeSat, until a small car site, like a smart car. So depending on the type of mission and depending on the type of customer, we can bring this payload capacity to orbit. But basically, the reference mission is 500 kilometers circular orbit, sun-synchronous, about 500 kilos. And depending if we are launching to equatorial orbits, you can reach a bit more than 1 ton to orbit.
And another thing that I wanted to talk about, it's you guys are putting yourselves into this goal of 30 launches per year by 2030, or 30 by 30, so to speak. That's sort of the chart that you guys showed in the Beyond event. How are you trying to scale up to be able to get to that point? Because it feels like it's a challenge to achieve. It's a challenge to achieve orbit, right? And then people don't get the cadence. How are you going to be able to achieve that?
Well, I actually think that it's harder to manufacture 30 vehicles per year than reaching orbit. So I think it's like the complexity level is finding resources to make an orbital launch vehicle, doing a first launch attempt, and then produce like 20 to 30 vehicles per year. So the production, let's say, increasing, so that evolution, the production capacity passing from 1 vehicle to 6 and passing from 6 to 30 is going to be quite challenging and quite demanding. The point is, the sooner we can start industrializing some technologies like turbopump machining, bulk serial production, composite production, as soon as we can start, let's say, industrializing these technologies, the better for high mass production. But I fully agree with you that probably will be harder producing 30 vehicles per year or 20 vehicles per year than reaching orbit at first.
Yeah, and I believe I saw a question in chat as well about that. What's going to be in terms of the priority when hiring? Because one of the things that you guys will need is also the workforce to be able to support all of those launches and be able to. I've heard from Ezequiel, the executive president. He was talking about this growth in employees. Recently, I saw a post as well from you guys. How are you going to be able to be able to do that? Maybe D can cue that exactly. Yeah,
Yes,
it's here.
so we have Methalox with a super chat saying, super excited for Miura 5. I applied for a software analyst role. Haven't heard back yet, but would love to join the team.
Yeah,
And
I
wondering,
will ask that. So,
and
yeah.
they're wondering what your top priority is when you're hiring.
Yeah, well, now, as Alex said, priorities set. Well, I would not set only in production, but especially in production, because engineering is almost made. There is lots of things yet to do, but it's still to be done. But now the big effort in our human resources team is production team, like people for machining, for milling, for welding, for metal curving, sheet curving, and all those integration people for both composites and metallic materials, turbo pump and combustion chambers integration. So there are lots of open positions for to apply. But certainly we find very good CB or someone that brings special even enthusiasm, or is bringing like some experience in some areas, as I mentioned. We try to interview the people, and usually we try to find people that can bring a mix between soft skills, like people that is like open, can cooperate with other people, like wide polyvalent for that, and also that hard skills of people that knows what have to do, and that commitment for the job, which is quite I would say hard, because we're doing a launch vehicle, and from the technology point of view is complex to manage, and there's lots of interactions, lots of things to take into account. But yeah, we're still super open for receiving as much CVs as we can. And actually, we when we launched Miura 1, PLD had 120 employees, and now we are 270. We made yesterday the announcement that we passed 250, but we are 270. So we double more the team in just 1 year.
Yeah, and one of the things that I also was quite shocked about, when you guys talked about the Miura 5 program, and so you want to scale up, but then at the same time, somehow you announce this thing of propulsive landing, right? Like it's not just gonna be the parachute landings. You're gonna learn about that and everything. Now also propulsive landing.
Yeah, actually, parachute landing is, or parachute technology, I would say, is the way we can make Miura 5 bringing safely, or probably one piece from space. So it's not the solution for making a sustainable, reusable process. So we can't, basically, we can't recover and reuse Miura 5 just using parachutes, because salty water will not allow us. So this is something which we know that, and it's not. We are not going to put so much effort on succeeding on using parachutes. So but can allow us to bring stage back and analyze it and see which type of things we should add, or how to fine tune the models to bring the stage back using propulsive landing. So propulsive landing has other drawbacks, because at the end you need to bring much more propellant on board that is not being used for reaching orbit, just to bring back the stage. So stage is going to be slightly larger to bring that propellant on board. But on the other hand, that propellant you are using for bringing the stage back is the one giving you the chance for basically bringing the stage and having one piece. So that combination between propellant you add for losing delta V, or losing performance to orbit, is the one is helping you to bring the stage back and break during some phases on reentry. But yeah, the goal is 2028, having the first Miura 5 going back to the path, and this is the objective we presented actually in the Beyond event.
Yeah, and that was, so one of the things that I had in mind after that was, how are you guys going to be able to recover the performance loss? Because obviously, to be able to come back, you kind of need to reserve the propellant. How are you going to be able to recover that performance loss, or are you okay with whatever performance that allows you to get to orbit?
Yeah, well, actually, there is one thing we need to test in flight, which is one thing, but several things we need to test in flight. One is the relight capability, reignition capability for the central engine, which is the one making the certain braking maneuver during re-entry. So at the end, the goal of the braking maneuver, the re-entry burn, is basically to reduce the heat flux in certain phases of the re-entry to just avoid burning the stage while you are re-entering. And this is something we need to test directly in space conditions and in the trajectory during the re-entry trajectory phase. So we will use the first Miura 5 to fine-tune the restart of the central engine to be sure that can work 5-10 seconds at the first times. This is the goal for the first attempts. But we know that the central engine to brake enough for a substantially high number velocity during re-entry has to work between 20 seconds to 40 seconds. This is the minimum time, depending on the trajectory, if you are launching equatorial or polar asynchronous, is the minimum time to reduce enough the heat flux during re-entry. This is one part. The other important part is about the GNC control authority. So as larger you make your vehicle, more hard it is to control. So to be sure that we can make the vehicle larger, we need to be sure on the margins we have on the GNC for controlling stage. So imagine that you have a very, very long vehicle. Control authority will be larger to keep because of the bending modes on the vehicle, based on the complexity of the body itself. So the solution is not just making the vehicle larger. There is lots of parameters to take into account, but basically we can make the vehicle slightly larger as other vehicles with a LD value higher than 16 or 18, which is the limit. Maybe we can make a Miura 5 slightly larger and add that extra propellant we need for braking.
That sounds great. And we were sort of talking about all of these improvements, not improvements, but rather the thing that you did with Miura 1 and then moved to Miura 5, and that sort of bridged the gap technologically, right?
Yeah.
So then in this Beyond event, you somehow announced this other bigger rocket, Miura Next. And so I know a lot of people right now in chat are probably watching from Spain, because I'm seeing a lot of people speaking in Spanish even in chat. So
that's great.
Like that to me, as a Spaniard myself, it was like, wait, we're making like this company is proposing to build this big rocket. And so it was this amazing thing. And by the way, people, if you're watching and you're liking everything here, just like and subscribe as usual, right? Make your questions at NASASpaceflight as well in chat, because these in the background picking those questions. We're gonna go to more of those here in just a minute. But I wanted to talk about Miura Next and that bigger rocket. Like, look at that. Like that's the family of Miura rockets, and it's quite amazing that you guys are proposing this. How did you come to this conclusion of let's make this?
Good question. So when business development team is going to the different technical discussions with customers, and they go to all the shows around the world, there are lots of customers asking us about which is next step, and also investors. We talk with these investors and they say, okay, we know you are going to launch Miura 5, you are going to bring back the money and pay back the money to your current investors using Miura 5, but what are you going to do in the next 10 years? So just the competition with other like big vehicles like SpaceX Falcon 9 or New Glenn or Vulcan vehicle or Ariane 6.4 or 6.2 or whatever, how we are going to compete with that? Because Miura 5 is the market, but do you expect to compete with different, let's say, size of vehicles? And in the early days of the company was not part of the ambition, because the only, as I mentioned before, we analyze the small market industry and the small market business. But when we started discussing with the customers and seeing which satellite they expect to do in the future, so not just us, but also our customers, they usually they try to do something larger than the things we can launch with the Miura 5. So after having that information, we said, okay, maybe we need to start like refunding the company again and think, which is the ambition for the next 10 years, and probably think on something else beyond Miura 5. That was actually the name of Beyond event. And that was the starting point for Miura Next.
Yeah, and we're looking here at the family there of rockets. And one of the things that a lot of people said back then, especially people that didn't know about PLD Space, is like, that's a very Carol looking rocket, right? Because it has a bunch of boosters as well. Because you have the single stake version, and now you also have the one with the 2 boosters, the one with the 4 boosters. What drove that decision to instead of building just a much bigger rocket, just put more boosters? Like, why did you come to that design decision?
Well, there are more companies proposing new launch vehicles with even with boosters, like even recoverable boosters. But when you develop a new launch vehicle, you have to think about the architectural configuration for that vehicle. You can think on solid boosters, you can think on no boosters, or larger performance or larger vehicle with bigger engines. So you think about and you make a trade-off of what information you put on the table to, let's say, to make your good decisions for a vehicle architecture. So, but basically there are 2 ways. You do a big vehicle and you want to increase the vehicle performance, or you do a larger vehicle even, or you put boosters. So there is no other easy way. So Miura Next in the single core configuration is the vehicle can be used for reaching low Earth orbit. So it's optimized not for GTO missions, it's optimized for low Earth orbit missions. But when I say low Earth orbit, is not just ISS orbit, it's all the missions that can need going, let's say, in the low Earth orbit, going to 3,000 kilometers, and even a bit more to MEO orbits. The point is that you can go to low Earth orbits, but you can still go into GTO or go to the moon. It's a different type of vehicle. It's larger than obviously Miura 5. Then if you ask to the business development teams, they say, okay, I want that vehicle, but I want also to cover the GTO market with a higher performance, okay? So you need a completely different type of vehicle, or you add the boosters. So that was the solution for the 2 boosters configuration, which is updated for GTO missions, and following some rationales for other Soviet era launch vehicles and not so old stuff vehicles like Falcon 9, for example, and Falcon Heavy. Basically, they are simplifying so much. Is just they are adding just boosters to make a more powerful vehicle. That has also drawbacks in the other way, but it's a potential solution. Just adding boosters. You see, SLS has boosters, Vulcan has boosters. Other vehicles has not boosters, like New Glenn, for example, or Starship, for example, because they are so big and powerful. They don't need those boosters. And if you go to the super heavy configuration with 4 boosters, the market is also completely different. You can launch more than 50 tons to orbit, which is not a real market today, at least what we know from the market. But thinking in the next 10 years, there would be lots of heavy payloads to be launched, not just on the low Earth orbit, but also in the moon and even beyond, Mars probably. So with the Miura Next family, you can cover, just simplifying too much, you can add boosters and select the mission you want to cover. That was the powerful solution for Miura Next, and that's the rationale we're going to follow as an architectural level.
Yeah, that was another thing that I saw you say on the Beyond event as well. That right now in Europe we don't have anything else that can right now we have very little capacity to launch from Europe, right? But also at the same time, when we had it, it was not very powerful. It was not as capable as the things that you're proposing.
Mhm.
And so it's like that to me feels powerful and ambitious. Like, how are you gonna be able to get to that point? Like that rough timeline to Miura Next. What do you think it's gonna be?
We will do it. So when we founded the company 13 years ago, I think 95% of people thought that were not possible to find 1 million for doing a rocket in Spain with a PowerPoint presentation. So now we're in a different position. We have a vehicle launch, a great team, good facilities, but obviously it's going to be tricky because we are passing from a medium-sized launch vehicle or heavy or small launch vehicle like Miura 5 to something which is competing with some of the largest vehicles in the world. So it's going to be hard too. But as you said, there is no a clear ambition in Europe, as far as we know, on heavy launch vehicles. It's something like, as Europeans, we prefer to delegate in China and the United States.
Yeah.
Our question was on why. We have a great launch base, which is French Guiana. We can open new bases in the future, even if we want to have more launch opportunities. Why not? So, and re-answering the question again, Europe is starting to pay for like mega Newton class engines, but there's no vehicle for that. Who is going to use the Prometheus engines? Who is going to use the new project they are running for super big engines? There's no ambition for super heavy launch vehicles, and in the other way, I think there is no big payload on the table now for those vehicles, but the market itself exists. So what seems that Europe wants is to relay in China and the US for doing that, and we will see in the television, and we are not that type of company.
Yeah, one of the things that sort of struck me, when you were doing that Beyond event was precisely that you said something along the lines of like, this way we can enter the true space race, so to speak. And
yeah,
that resonated with me, of course, because I'm totally on board with that. And right now, for example, just this week we heard this sort of talk about the future of Vega, for example, how they want to launch maybe 4 times a year next year, and how their cadence is just limited to 4, and Ariane 6 is also limited to just 12 and things like that.
12.
Like, yeah.
I can't imagine that. So European competitiveness is passing through those numbers, and I think that is not competitive. So we should do something different, because if not, we think that launching 4 per year is something great, and you compare the numbers with the Falcon 9 and you go depressed. But if you think on other, I'm not thinking on the US market now, I'm going to think on the Chinese market. Just see how many launches per year has China or even Russia, and compare with Europe. So if you compare the GDP of those countries with the European Union, probably we are doing something bad, extremely bad. So our position is we are doing what we promise, and when we put a way to work, and when we define a target, we try to accomplish that. And what we said 2 months ago was we are like refunding the company, and what we are saying is we're going to start working on heavy launch vehicles because we think that Europe needs that, and there is no leadership to push, but we have that, and we are going to push.
And speaking of that push, the last thing that we have here, sort of in the list of things, which I left till the end. It's already almost an hour. I don't want to push you beyond your allotted time, but this Linthe project, right?
Yeah.
Like how it's it's already amazing to see this big rocket, but now also a capsule to your cargoing humans. Like, how did you come to that place?
Well, actually, Miura Next single core design is let's say is driven by the need for lymph capsule. So basically, when you want to launch a human means into orbit or astronauts into orbit or just cargo to certain space stations, the simplest solution you can use is a 2 stages launch vehicle, because it's hard to go into orbit with a single stage launch vehicle, and some companies try to do that, but 2 stages is the simplest solution. So Miura Next single core is the vehicle for the capsule, and the capsule itself is something completely new in Europe. There was back in close to 20 years ago certain paper projects for doing a capsule. Unfortunately, they didn't pass, I think, from 1 or 2 desks. So no so deep analysis on what is the configuration for an orbital capsule, which is the needs for subsystems, what you need if you want to bring astronauts into orbit and bring back those astronauts from orbit. So I think European Space Agency, they did the job for trying to start this process of developing a manned capsule. But I think that probably politicians, they didn't vote the solution. The point is that money comes to the space agency on the different governments, and that, depending on the interests of the particular countries, the projects can go or not. We are out of that. What we said is, okay, if we are thinking on the next 10 years and someone in Europe needs to launch astronauts, because of that, we have an astronaut team in the European Space Agency, and there's a budget, yearly budget for that. Our astronauts needs to have a capsule for launching, safely launching into orbit, and we started working on that. Actually, we started working at the same time we're launching Miura 1. That's the name of Lymph 2, which is a very protected animal in the area where we launched Miura 1. And that was the name for that project. And we were running the project in the shadow for 1 year. We presented in October 7th, last 2 months ago. And now we are working on that. The goal is having the first capsule by 2030 and try to do the launch attempt.
Yeah, and I remember being there. We were showing some of those pictures that I took when I was there. Because I asked, it was like, is this like a mock-up or something? And
No.
Raúl Verdu, the other co-founder, he told me, no, this is for real. This is not cardboard or anything.
No,
This
no.
is a thing we built, and so
Yeah,
that is.
we call it engineering model 1, which is the obviously one engineering model and the first one we do. And the goal of Lymph engineering model 1 was to basically manufacture a full-scale capsule, adding from the structural level all the main components on the structure, adding manufacturing techniques similar to the ones we're going to use, basically in some cases actually the same manufacturing techniques and same materials we're going to use for the capsule structure, adding seats, adding some screens and some cockpits for astronaut control, and to put astronauts inside. So using the capsule as a way to obtain information from the astronaut behavior when they are inside. So the use of this engineering model now is basically receive information from astronauts that can come to PLD and say, hey, when I'm put inside of the capsule, I want to have this cockpit here. I want to have this space between my leg and the other astronaut or whatever. All the information can bring us from the ergonomic point of view, from the functional point of view, information to create the next version, which is going to be called engineering model 2, which is an evolution in the inside part of the capsule. So let's say in the environment where the astronauts are. But from the outside point, the capsule will have all the final configuration from materials, thicknesses, and manufacturing techniques to allow a drop test. So we'll do that drop test using a Chinook helicopter, using parachutes, and we will start testing in the same fashion we did with Miura 5 early days for drop testing to recover information about the dynamics during parachute jettisoning, stability during free fall, and water impact.
Yeah, I cannot wait until we see that, and definitely, you know, again, it's sort of like national pride kind of thing, right? Of being able to see this, and definitely, you know, wishing you guys lots of luck. I'm gonna go now to D because I want to see if we have some questions. I know we're already a little bit beyond the time, but if we have a couple more questions, we can hit.
Yeah, so Krypton13 is asking if there's any chance moving forward of having a launch pad in Spanish soil, maybe the Canary Islands.
Yeah, good question. I think I had that question lots of times, hundreds of times. It's a really good question. Well, unfortunately, Canary Islands are in it's not a bad place because you can launch to north or you can even launch to south. Let's say to polar orbits, but there is no so many places when you can have the launch site, the physical site, with good safety conditions. So there was another project we were participating 2 years ago, more or less, called Plocan, that was basically an oceanic platform in the Atlantic coast of the Canary Islands to put the launch vehicle. The problem with Canary Island launch base is that the market you can achieve launching from the Canary Island is so small. So the azimuth the access to orbit you can have from that part of the world is not so big to pay back all the investment you need to do on the base. You have to add that the tracking stations, especially in the far range, are not going to be available. So you have to make the investment for the tracking stations. So it's not a really good solution. So that was the reason we were going to French Guiana, which is the European spaceport, has been paid by the European citizens with the taxis, and we have to use it, not just by the people is using until today, the Arianespace and Avio. So we think more entities has to participate in the European spaceport activities. So more people running there, more people using the facilities, and new investment to come. But Canary Island definitely is like a small opportunity for Miura 5 market.
Yeah, and you haven't thought about any other places, right? Or just French Guiana.
No. We did a great analysis from other potential spaceports, not just in European territory like Shetland Islands or Andoya or Kiruna or the other places in the north, let's say North Europe. But we receive people that are running other spaceports in Canada, in Australia, in Middle East. So people that wants to promote new spaceports because they see that there is a great market for and great way of promoting the regions with this market. So now we're in the phase of closing a second spaceport for Miura 5, and it's something will be announced.
Really looking forward to that. Let's hope we get some exclusive news out of that. But it's been a pleasure to have you here, Raúl. And again, so many things being planned. Of course, wish you the best luck as always. And I'll take your word for it. You told me, October 7th, 2025, you'll be there. Sign the rocket and everything. I'll take your word for it, and hope you guys come here again soon, and have many more times here with NSF as well. Thank you very much.
Thank you very much, and thanks for giving me the opportunity of being here. Much appreciated. Thanks for the team is following us on YouTube, and happy to be here again.
Yeah, anytime. And guys, you are probably watching. If you like this, please, the usual YouTube thing, like and subscribe and whatnot. And thank you all for watching. We had obviously Dee in the background as well. And thank you for all of you. You know, bringing those questions in, trying to sort through all of the. I've seen a lot of people there in chat, and they are all Spaniards and everything. I gotta say, maybe some people are not watching from Spain. I don't know, but hey, we had a very good Spanish audience here in the chat, and thank you, Dee, for coming through all those questions.
Of course.
And of course, thanks as well to Jay in the background, you know, pulling the levers, pushing buttons and everything, as Jack usually says. And of course, I've been Alejandro Gandarilla Romera. That's a very long name, I guess, to go through. And of course, you can, you know, expect many more of these in the future. Of course, we're going to be talking to many other industry officials in Europe. And so make sure to tune in when we go live for those, and of course to every other thing that we go live, because it's kind of bonkers, all the things that we cover. And of course, you see, I'll see you all on the next one, I guess.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, roll, Atlantis.
Water towers, fly! Yes! Tango down to nominal.
Flight downside speed off. Bring in SPD off. Off.
It's orange!
Oh my God! Oh my God!
Decollage.
Look at this.
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.